Okay, so for cis and trans, you might think you're drawing the same molecule, but it has to do with a little bend and a twist. And I'm going to show you a model here in just a minute. So when you go to write this, start with hexene, so that's going to be 6 carbons, and on the third carbon is a double bond. So I'm going to have 1, 2, 3, 4, 5, 6, and on the third, 1, 2, 3, there's going to be a double bond. So this is hexene without the hydrogens. I'm just going to leave the hydrogens off. Well, you go, well, these are the same, 3 hexene, 3 hexene. So now I got to prove cis and trans. So I'm going to show you a model on how that works. So this is linear, and they're not linear. When you make an organic molecule, they actually have bends and twists in them. So here's an example of a trans, 3 hexene, and here's an example of a cis, 3 hexene. So if you look at the carbons, again, you go 1, 2, 3, and on that third carbon, I have a double bond. There it is, the 2 double bonds, and then 4, 5, and 6. So I have that, same thing, and check this one out. 1, 2, 3, and there is a double bond. 4, 5, 6, and 6 carbons. So these are the same molecule, but when you just look at them here, they don't look the same. That's the point of cis and trans. They usually use it in pharmaceuticals, and it means a difference between different types of like isomers of the same type of molecule. So you can identify your pharmaceuticals and the difference between your pharmaceuticals by how the carbons are either turned up and they're identical to each other, across from each other. So my 2 carbons are turned up and across from each other. Or they're trans, where this rotates and it's down and away. So I've got 1 down and 1 up. So you're not looking at the double bond as much as you're looking at these guys sitting out here. So again, rotating is what's causing the cis and the trans. So when they're directly in line with each other, that's going to be your cis. When they arc and they go opposite directions, like this, that's trans. So then I redraw this molecule so it's not flat structure, and I want to draw it to look kind of like this. Then I'm going to have a C, double bonded C, and one of these guys is going to be up and bent, and out and bent. There's your trans. And these represents carbons, carbons. I can show you the skeletal structure. It'll be like this, double bonded up and click. So that's the skeletal. And then for the cis, it's going to be your carbon, double bonded carbon, and this time you're going to have the 1 up and another 1 up. So kind of like little antennas, and the skeletal structure of that is going to be 1 up, over, double bond, and up. So now you can really see the cis and the trans in this.